In the early 1800s, the world was sure it knew what power was. It was something you could see, something you could hear, and definitely something you could feel. Think of the Industrial Revolution. Massive steam engines, hissing and clanking, water wheels turning with incredible force, the deafening sound of metal striking metal. Power was all about contact. It was physical. It was mechanical. For any machine to work, something had to touch something else. Gears had to mesh perfectly, thick leather belts had to pull heavy loads, and powerful arms had to push and shove. Power was always visible, always tangible. This very idea, this belief that power had to be something you could see and touch, actually limited how people thought. It put a fence around the imagination. If a force couldn't be seen, how could you possibly control it? And if you couldn't touch it, well, you certainly couldn't trust it. But then, a man named Michael Faraday started to notice things that didn't quite fit this picture. What made Faraday different was his background. He wasn't a formally trained mathematician who saw the world through complex equations. Instead, he was a meticulous observer. He approached nature with a kind of relentless patience, watching and wondering, while all his contemporaries were looking for force in the clatter of moving parts. Faraday started looking for it in empty space. He would sprinkle tiny iron filings on a sheet of paper over a magnet and just watch. He saw these beautiful, elegant patterns emerge where there was seemingly nothing at all. Invisible shapes, invisible structures were organizing the filings. It was clear that some kind of force was acting at a distance, without any physical contact. To most scientists of the day, these patterns were just neat little tricks, curiosities maybe, but not fundamentally important. They were just side effects of magnetism. But for Faraday, they were much more. They were evidence. Hard evidence that power didn't always need contact to travel. It could move through what he would later call fields. Now, you have to understand just how radical this idea was. It went against centuries of scientific thought. The very concept of force without touch sounded absurd, almost like magic or mysticism. But Faraday was stubborn. He trusted what he could see with his own eyes, what his careful experiments showed him, more than he trusted old ideas. So, he began a series of groundbreaking experiments with electricity and magnetism. At the time, these were two very mysterious phenomena, and most people treated them as completely separate things. But Faraday noticed something deeply unsettling, something that connected them. He found that an electric current could create a magnetic field, and in turn, a magnetic field could influence electricity. This was a revelation. They weren't two separate forces at all. They were like two sides of the same coin, different manifestations of the same deep underlying reality. And this reality didn't need pistons or gears. It didn't need anything to crash into anything else. This power existed in the empty space itself. Faraday gave a name to these invisible regions of influence: fields. He described them as areas where a force existed, ready to act, even when nothing was moving. This was a dangerous idea, and it threatened to turn the entire industrial world on its head. If power didn't require contact, then machines didn't have to be clunky mechanical things anymore. They could be something else entirely, something silent and invisible. The world, powered by steam and steel, was not ready for that thought. Steam had given humanity a sense of control because you could see the pistons moving, you could feel the heat. Fields, on the other hand, offered something far more abstract, something you had to take on faith. But Faraday didn't stop. He pressed on, driven by his observations. He set up an experiment to prove his point, demonstrating that you could create motion without any gears touching, without any belts pulling, and without any arms pushing. He showed that a simple copper wire, a conductor moving through a magnetic field, could generate an electric current. Think about that. Motion created energy. And in another one of his inventions, the electric motor, energy created motion. And the crucial part was that neither of these processes required any physical contact between the source of power and the thing being moved. Power had suddenly lost its familiar shape. It had become invisible, silent, and far more powerful than anyone had ever imagined. The world just hadn't quite realized it yet. Faraday had unlocked a secret of the universe, and in doing so, he laid the foundation for the modern world we live in today, a world powered by invisible forces. Have you ever wondered what the most powerful force in our world is? Is it a giant engine? A massive rocket? A towering dam? You might be surprised to learn that the forces that run our modern civilization are completely invisible. Before Faraday, a machine was something you could see and touch. It was a collection of gears, pistons, and levers, all clanking and grinding together, usually powered by the violent force of steam or combustion. Think of a steam locomotive, a powerful but messy beast of iron and fire. Power was something physical, something you could watch happen. It was a world of mechanical force. But Faraday changed everything. Through a series of elegant and brilliant experiments, he discovered something profound. He found that power could flow without any visible movement between parts. He revealed that energy could exist as a kind of tension in empty space. He called these invisible structures fields. Fields surrounded wires carrying a current. Fields surrounded magnets. In fact, fields filled the air all around us. This wasn't just a quirky scientific curiosity. It was a fundamental shift in our understanding of reality. Suddenly, power was no longer confined to metal pipes or spinning wheels. It was no longer limited by physical contact. This single insight gave birth to the electric motor. For the first time, you could have a machine that worked with no visible moving parts pushing each other. An invisible force did all the work. From motors came generators. Now we could create electrical energy, transfer it over long distances, and then transform it back into motion, all without the noise, smoke, and inefficiency of steam. The age of electricity began not with a bang, but with a quiet, invisible hum. Think about what this meant for industry. Before Faraday, a factory was built around a single, massive steam engine. A complex web of belts and shafts would distribute power from this central heart to all the machines on the factory floor. It was dangerous, inefficient, and incredibly restrictive. But with electricity, everything changed. Factories no longer needed that central monster. Power could be distributed through simple wires. Small, efficient electric motors could be placed on each individual machine. This allowed for incredible precision and control. It made factories safer, cleaner, and more productive. The layout of our cities, the design of our homes, the very way we work and live, was reshaped by this ability to send power invisibly wherever we needed it. What's fascinating about Faraday is that he wasn't really an inventor in the traditional sense. He didn't rush to patent his discoveries or build commercial engines. He was a pure scientist, driven by a deep desire to understand the fundamental laws of nature. He famously said, "Nothing is too wonderful to be true, if it be consistent with the laws of nature." He believed his job was to build understanding, not machines. He laid the foundation, knowing that others would come after him to build upon it, and they did. The great physicist James Clerk Maxwell took Faraday's ideas about fields and gave them a rigorous mathematical form, creating the famous Maxwell's equations that are the bedrock of modern physics. Engineers then took those equations and used them to design the generators, transformers, and motors that power our world. Industries took those designs and scaled them up, building the vast power grids that stretch across continents. But it all comes back to Faraday's fields. Without them, there are no electric motors. Without the concept of an invisible force doing work, there is no modern world as we know it. Today, we are completely surrounded by the legacy of his discovery. Electricity flows unseen through the walls of our homes. Magnetic fields silently guide the motors in everything from your phone's vibration to the hard drive in a data center. Energy moves across the globe without friction or flame, a silent, invisible river of power. Think about the most advanced technologies we have today. Computers, the internet, artificial intelligence. At their core, they all run on electricity. They are all powered by Faraday's invisible fields. We mechanized logic with computers. We wrote instructions in code, and now we command an invisible force to carry out our will. Michael Faraday did more than just discover a new law of physics. He revealed a completely new way that reality could work. He showed us that the most powerful forces are not always the ones we can see. He taught us that power no longer needed to be a violent, mechanical act. It could be silent, elegant, and everywhere. The modern world doesn't run on steam, it runs on fields. And once humanity learned that power could be invisible, there was no turning back. So the next time you flip a light switch or charge your phone, take a moment to think about the silent, invisible force you're commanding. A force first unveiled by the brilliant mind of Michael Faraday. Thanks for watching. If you found this journey into the invisible world of energy interesting, Do you and forget to like this video and subscribe for more stories about the ideas that shaped our world. See you next time.